Okay, so this is the review for the Integrated 3 first semester final exam. Let's start already. Let's get to work. The first three problems are the same instructions. It says, name the shape of the cross-section produced by slicing each of these solids as described. Okay, so number one says a vertical cross-section of a cylinder. And actually number two is also cylinder, a horizontal cross-section of a cylinder. Now I cannot draw those cross sections because I'm not good at drawing, but imagine a cylinder, right? There's a cylinder right there. And the first one says a vertical cross section. She's going to cut straight down from top to bottom through that cylinder with a plane. And number two says a horizontal cross section, which is the same thing. Take a plane and cut right through that cylinder to see what it looks like. Now this is a very bad drawing, so here let me show you guys what it would actually look like. I'm gonna see if I can find an image that could help you guys figure that out. Let me see. Okay, so I found this one online. Definitely much better than what I would have come up with. So this would be the perfect example of what. Let me make this smaller right here. As you can see, of what this is asking us for, right? There's the one on the left is a horizontal cross section. There's a cylinder, and you're cutting right through it. So what you have left is a circle. Okay. The one on the right is a vertical cross section. You're cutting right through from top to bottom with a plane, and what you have in that as a cross section is a rectangle. Okay, so it's about visualizing what that would look like if you were to cut right through it with a plane. Number one then is a rectangle, and number two would be a circle. Okay, all of these cross sections, just visualize what that shape looks like, and then think, I'm gonna cut right through it. What is what I get as a cross section right there? Okay. Number three says a vertical cross section of a square pyramid, but not through the top vertex. Okay, so again, I cannot draw a cross section, but let's try to see if I can find an image for that. Okay, so picture a square pyramid, and then you're cutting right through it vertically, but you do not want to go through the top vertex. Okay, so let me see if I can find an image of that. Okay, so I found this image right here of a vertical cross section. Now this is not the one they're asking you for. I just wanted to show you, also show you what this one would look like. Okay, this one is a cross section of the pyramid, but it passes through the top vertex. So you guys can see that it passes through the top vertex. So what kind of shape does it create once it crosses through is a triangle, and you can see how it forms that triangle right there. Okay, that's not the one we want though, so let me show you guys the one that actually would work in this case. I'm gonna add that one. This is the one that we are looking for. Okay, if you look at this image right here, there's a cross section, but it doesn't cross through the top vertex, but it still creates this shape as it cuts through it. Okay, and you can see that shape highlighted in green right there. Let me go through it in black as well so you guys can see it. Once you cut through this with a plane and you do not pass through the top vertex, the bottom side of your shape will be longer than the top side. Okay, the sides will be exactly the same size since the plane you're cutting with is vertical. Okay, so what would we call this kind of shape? It's called a trapezoid. Okay, so the answer to number 3 would be a trapezoid. Okay, let's move on to number 4. It says find the surface area of each composite figure, show your work. So it says there's a cylinder on top of a rectangular prism, as shown in this figure right here. Okay, now in order to not make a mess of things, because there's so many different things to find out, I'm going to make sure we use the correct terminology. Okay, so I'm going to separate out my work for the rectangular prism, which I'm just going to call a prism, and the cylinder, which has different formulas, although they're very similar, right? So we're looking for the surface area. Now if you recall, the surface area of a prism is 2 times the area of the base. Now since I'm going to use the area of the base for the cylinder over here as well, I am going to call the area of the base of the prism as B sub P. So I know that it's the area of the base of the prism, not the cylinder. Okay, so it's 2 times the area of the base plus the perimeter of the prism again. Well, I don't need to specify that one because for the cylinder it's going to be called the circumference, not the perimeter. Okay, so times the perimeter of the prism times the height of the prism. I'm going to call sub P everything that has to do with the prism. Okay? That's the formula for the area of a prism. For the area of a cylinder is 2 times the area of the base once again, but now we're talking about a cylinder, so sub C, plus the circumference of that cylinder times the height of that cylinder, so H sub C, to identify it from the height of the prism. Okay, so I'm using those just so I can, because there's 2 different shapes here, so I know which one's which. Okay. So on the prism though, I don't need a full prism. Okay, if you look at it, there is a full prism here for which I need to find the surface area, but it's missing this piece because it's being covered up by the cylinder. Okay, so I do need this formula, but I'm not going to find the total value. If I want to find just the surface area of the actual stuff that I have, I need to subtract that circle that it's missing. Okay, and what is that circle? That's the area of the base of the cylinder, right? B sub C. And that, once I do those calculations, will give me the surface area of that prism part. For the cylinder, same thing. I don't have 2 bases. If you look at the formula for the cylinder, there's 2 bases plus the circumference times the height, okay, which is basically the lateral area. I don't need 2 bases. I only have 1 base, which is right here, okay? I don't have that bottom base over there, okay? So instead of 2 area of the base plus C times H, all I need is 1B. I'm just going to erase the 2 to show that. All I need is 1B instead of 2B. And there's my formulas. Once I figure those out, I add them both to each other and I'm done. Okay, I'm going to add the area over here of the prism and I'm going to add the area of the cylinder, and that'll be my final answer. Before I do that calculation, there's something else that you should notice. Notice that here I am subtracting B sub C, the area of the base of the cylinder. And over here I have B sub C, the area of the base of the cylinder. Since I'm subtracting it here and adding it here, they're just going to end up canceling out. Once I put both of these together, those 2 are going to cancel out because one is minus, the other one's plus. Which makes my job easier. Now all I have to worry about is these pieces right here. All I have to do is find 2 times the area of the base of the prism plus the perimeter times the height of the prism, and then I have to find the circumference and the height of the cylinder and multiply them times each other and add everything together. Okay, so I don't need that part. Alright, let's do the calculations. 2 times the area of the base of the prism. So I have to find, let me just cross this out so we don't get confused. That's part of the next problem. I need to find the area of the base of the prism. I need the perimeter of the prism. I need the height of the prism. I need the circumference of the cylinder, and I need the height of the cylinder. Once I find all of those things, I'm ready to plug them in and solve. Okay, so the area of the base of the prism, the base is a rectangle where one side is 30 and the other side is 10, so that area is 30 times 10, which is 300. The perimeter of the prism, this side is 30, this side is 10, so 30 plus 10 is 40, but that's not it, right? Because there's another 30 over here and another 10 here, so 30 plus 10 plus 30 plus 10 will give you 80. The height of the prism is right there, 12. The circumference of the cylinder, okay, the formula for the circumference, if you remember, is 2 pi r. Okay, so let's draw 2 pi r, and r in this case is not 8, right? The diameter is 8, which means that the radius is 4. So 2 pi 4, which is 8 pi. Let's just write 8 pi there. And finally, the height of the cylinder is 5. All right, plug all those numbers into your formulas, add them all up, and then you'll be done. Okay, so right here we have 2 times the area of the base of the prism, which is 300, plus the perimeter, which is 80, times the height of the prism, which is 12. And then if I continue going here, I'm just going to go ahead and add this part over here. The circumference of the circle, which is 8 pi, times the height of the cylinder, which is 5. There you go. And in this case, you might need a calculator. So this is going to give me 600 plus 80 times 12 is 960 plus 8 pi times 5, which is 40 pi, right? 8 times 5 is 40, 40 pi. All right, I'm going to add the 600 and the 960 together. Gives me 1,560 plus 40 pi. Now, if it says leave your answer in terms of pi, then you're done. But if it says round your answer to the nearest tenth or the nearest hundredth or whatever it says, then go ahead and do this calculation. Find 40 times 3.14 for pi, and then add 1560. So in that case, it would be, use a calculator here, it would be 1,685, and then to the nearest tenth, let's leave it as 0.7 or 7/10. Okay, square units, of course. It doesn't say what kind of units we have, but it's square units. All right, number 5 is a much simpler one. Okay, it's just a basic cylinder, nothing composite about it. So you want to find the surface area. You're basically just going to use the formula. Surface area of a cylinder is 2 times the area of the base plus the circumference times the height of the cylinder. Okay. So we need 3 things in this case. We need B, the area of the base. We need C, the circumference of the base. And we need H, the height of the cylinder. Okay. So H is easy to find. It's 11. You can see right there that the distance from one base to the other is 11. The circumference is 2 pi r. And the base is pi r squared. So let's do 2 pi r quickly and easily because that one's much faster. 2 pi r, r is not 8 but 4, right? So 2 times 4 is 8. That's going to be 8 pi. The base over here, let's move this h over here so I could have space. The base over here is pi r squared. R once again is 4, so 4 squared is 16, so therefore it's 16 pi. Those are your values. Plug them into your formula right here and you'll be done. So it'll be 2 times the area of the base, which is 16 pi, it's an equal sign right there, plus the circumference, which is 8 pi, times the height, which is 11. Okay, put those together. I'm going to continue up here so I can finish my work. That's going to be 32 pi. 2 times 16 pi is 32 pi. Plus 8 pi times 11, which is 88 pi. Add those together. Since they both have pi, you can put them together and you're going to get 120 pi. And that's it. If the question says leave your answer in terms of pi, you're done, 120 pi. If it says round your answer to the nearest tenth or the nearest hundredth or to 2 decimal places or something like that, then go ahead and multiply 120 times pi, 3.14 in your calculators. Okay, in that case you will get, let's get a calculator here, approximately 376.99. Let's leave it to 2 decimal places on this one. Square units. Okay, number 6 is a triangular prism where the height of the base is 25 and then the other measurements are given right there in the picture. Okay, so prisms, once again, the formula is the same for all of them. The surface area is 2 times the area of the base plus the perimeter of the base times the height of the prism. Okay, so in this case I need to find what B is, I need to find what P is, B for area of the base and P for perimeter of the base, and I need to find what H is. Okay, H for the height of the prism. Remember, that means the height of the prism, not the height of the base, okay, which are 2 completely different things. The height of the base is 25, which is this little distance right here, right? It goes from the top corner of your triangle all the way down because the base is a triangle here. What I mean by h here is the height of the prism, which is the distance from one base to the other base, okay? Which in this case is 16. Do not confuse those two. Okay, the height of the prism is 16. It's the distance from one base to the other base. All right, now let's find the area of the base then, okay? Now since the base is a triangle, you guys can see that there's one triangle, there's another triangle, there's two of them. Since the base is a triangle, the formula is 1/2 base times height, right? It's a triangle. And what I mean by base, once again, I know this might be confusing because there's too many bases now and there's too many heights, okay? What I mean by base is the base of the triangle. Think of it as just a flat triangle. The base would be considered this side right here, which is 43, okay? And h here is the height of the triangle, which is this distance right here, which is what they gave me over here, which is 25. So I'm going to use those numbers to calculate the area of the base. So it's going to be 1/2 times 43 times 25. 43 is the base of the triangle, 25 is the height of the triangle. And for that, just go ahead and multiply using a calculator. And you get 537.5 square units. Okay, that's a 5 right there. Just fix it so it looks nicer. 537.5. And finally, the perimeter of the base. Once again, it's a triangle. The base is a triangle. So I need to find the perimeter of it. This side is 43. This side is 28. And this side is not written here, but it's written up here. It's 40. So to find the perimeter of a triangle, just add up all three sides. So it's going to be 28 plus 43 plus 40, which gives me 111. And now I take all those three values and I will substitute them in right here into the formula, and that'll give me my final answer. So then I will get the surface area is 2 times the area of the base, which is 537.5, plus the perimeter of the base, which is 111, times the height of the prism, which is 16. Do those calculations and you will get 1075 plus 1776, and your grand total will be 1075 plus 1776 is 2851 square units once again. So let's just recap what we just did here, okay? We found the surface area by using the same formula we always use for prisms, 2 times the area of the base plus the perimeter times the height, which is called the lateral area of this prism. Okay, we found the area of the base using the formula for a triangle, 1/2 base times height. We found the perimeter of the base just by adding all three sides since it's a triangle. And we find the height of the prism because it was given right here. And the height of the prism is not the same as the height of the base. The height of the prism is the distance between the two heights. So use those three values, substitute them into the formula, and we got 2851. Alright, number 7, we have a cone, which might have got cut off in the paper as well. It got cut off on mine. So just so you know, the radius of this cone is 4 feet down there. That's what the missing information there. Okay, so it says what is the base area of the cone and what is the lateral surface area. Okay, so let's recall the surface area of a cone is equal to the area of the base, which is B, and there's only one base, right? Plus the lateral area, which is given by pi r L, which represents the slant height. Okay, so or you could write this as, instead of B for area of the base, we use pi r squared. Since the base is a circle, the area of the base is a circle, it's pi r squared plus pi r L. Right? So number 7, first part is it's saying what is the base area of the cone. So what is basically this part only? What is pi r squared? Okay, so let's do that calculation. Since they gave us r, which is 4, it's going to be pi times 4 squared, which is going to be 16 pi. Done. What is the lateral surface area? That'll be pi RL right there. Okay, and to use pi RL, the lateral surface area, I need to know what L is, the slant height, which is not given to me in this problem. Oh yeah, it is. Never mind. I just saw the 12 feet, but look, 12.6 feet right there. That's the slant height. Okay, so use those values and we can find the lateral surface area. Lateral surface area, the symbol we use is capital L. So it's going to be pi times R, which is 4 still, times the slant height, which is 12.6 feet. Multiply those out, and we get 50.4 pi. Alright, and the final part of number 7 is asking us what is the total surface area then. Okay, so add those two surface areas that we just found, which are 16 pi and 50.4 pi. 16 pi and 50.4 pi. Together they add up to 66.4 pi. Now if they ask you to round it to the nearest tenth or so, remember multiply times 66.4 times 3.14 to get a decimal approximation, which in this case would be 208, approximately 208.5. Okay, and here we have a pyramid. It's a triangular pyramid where the base is a triangle, but the formula for the surface area of a pyramid, of all pyramids, is basically the same thing. It's going to be surface area is equal to the area of the base, the area of the base, plus 1/2 the perimeter of the base times the slant height, L. Or you could always write those as 1/2 PL plus area of the base, right? You don't have to write it in this form. So in this case, I need to figure out what B is, and I need to figure out what P is, and I need to figure out what L is. There's 3 things I need to figure out so that I could plug them into my formula. Okay. B is the area of the base. In this case, the base is a triangle, so I need to figure out the area of that triangle. Now, in order to complete this surface area, I need to find the area of the base, the perimeter of the base, and the slant height. So I think the easiest one to find would be the perimeter of the base. Okay, this is assuming that this base is an equilateral triangle. Okay, this is a regular pyramid, or else our formulas are not going to work. So if it's a regular pyramid, that means that it's an equilateral triangle in the base, which makes this 9 and the other side 9 as well, right? 9, 9, 9. So the perimeter is basically going to be 9 plus 9 plus 9, which is going to be 27. That's the easiest one to find. The other ones are going to be a little bit more challenging. Okay. Now for the area of the base, that one's going to be the most challenging. Let's look at the slant height, L. Okay. The slant height is not 10. This is not the slant height. The slant height goes from the highest point in our pyramid straight down to the midpoint of one of these sides. Okay, so it will look something like this. If this is the midpoint of the sides, I'm estimating here, it'll go straight down from there to there to make a right angle right there. Okay, so how am I going to find that distance right there? By using this and the Pythagorean theorem. Okay, so this distance from here to here, if the full thing is 9, this little distance right here is 4.5. Right? Now using that 4.5 and that 10, I can say a squared plus b squared equals c squared, where the missing one is not c, but either a or b, depending on how you set up your Pythagorean theorem. So let me write it down. The Pythagorean theorem says a squared plus b squared equals c squared. Now in this case, I know c is 10, so c squared is 100. Right? How do I know c is 10? Because it's the hypotenuse of my right triangle. And then I know a or b, 4.5, right? I'm going to call it b is 4.5. So it's going to be a squared plus 4.5 squared, which is 20.25. And then I solve for a by subtracting 20.25. I'm going to get 79.75, and then take the square root of both sides to get a is equal to the square root of 79.75, which is approximately 8.9. Okay, and that is L. Approximately 8.9 inches. All right, now the tough one is the area of the base. Now to find the area of the base, I'm going to go ahead and draw a equilateral triangle up here to show you guys a little better. Okay, in this equilateral triangle, this side is 9, this side is 9, this side is 9. Actually, better yet, instead of writing 9 here, I'm going to cut it in half and write 4.5 right there. Why am I doing that? Because I'm trying to find the area of this triangle. In order to find the area, I need to know its height. I know its base is 9, but what's this height right here for this triangle, right? So if I know that this side is 4.5 and this side is 9, this side is 4.5 and this side is 9, I can use the Pythagorean theorem to find this height, which is what I'm going to do right now. Okay, so once again, a squared plus b squared equals c squared. In this case, I don't know a squared, the height, but I know b squared, which is 4.5 times 4.5, which is the same number I found before, 20.25. And then I also know c squared. C is 9, so c squared is 81. I solve that and I get a squared equals 81 minus 20.25 is 60.75. And then I take the square root of both sides. And so a will be approximately the square root of 60.75, which is 7.79 or 7.8. Okay, that is just this right here. Okay, that is the height of my equilateral triangle, 7.8. So now with that, I can find the area of this equilateral triangle, right? The formula for the area of a triangle is, let me erase this work so again I can use this space to work because this is the only space I have. The formula for the area of a triangle is 1/2 base times height. Oops, not capital B. So used to writing capital B right now. B base times height, right? The base of this triangle is 9. Right? That's base in a triangle means just what's the length of the bottom side, or this side or this side. Either one could be the base, right? 9, and the height is 7.8. So multiply those out, and I get 35, approximately 35.1. And that is the area of the base. All right. I found the area of the base, I found the perimeter of the base, and I found the length, the slant height. I can plug them in, all in, and I can find the total surface area. So let's do that. The area of the base is 35.1. Oh, that's basically this part right here. The lateral surface area, what they mean by the lateral surface area is this part right here. So 1/2 the perimeter times the slant height. So it's going to be 1/2 times 27 times 8.9. Okay, multiply those out and we get approximately 120.15. And so the total surface area, add those two up, and you're going to get 155.25. Approximately, right? This is not exact. And there you go. That is definitely the toughest one to find the surface area for. If not the toughest one, at least the one that takes the longest, because there's a lot of calculations that you need to do before you actually get to use the surface area formula. Okay, let's move on to number 9. It says, state how each transformation affects the area. Number 9, the base of a parallelogram is multiplied by 3/4. Okay, now here's an important thing to remember. If you change any of the dimensions by any factor, you multiply it by something of a shape, what will happen to the area? It will change by exactly that same number. So for example, in this case, if I change the base only of the parallelogram by 3/4, then the area will be multiplied by 3/4 as well. It's the exact same change that you did to that base. Now there is a difference if instead of saying the base of a parallelogram is multiplied by 3/4, it said something like all of the dimensions of a parallelogram, meaning the base and the height of a parallelogram are multiplied by 3/4, then the area would not be multiplied by 3/4. The area in that case will be multiplied by 9/16, which is basically 3/4 square, right? The square of that number. But since they're only changing one dimension here, then the area only changes by that one single number. Number 10, say basically the same idea. A rectangle has a length of 12 yards and a width of 11 yards. The length is divided by 6. What will happen to the area? Since they're only changing the length, not the width, they're only changing one dimension, then the area is also divided by 6. Whatever the old area used to be, it now is a smaller number, which is divided by 6. Okay. Once again, I must specify that this is only because they're only changing one of the dimensions. They're only changing the length. They didn't change the width at all. So the area basically has the exact same change. If it had said the length and the width are both divided by 6, then the area would not be divided by 6. The area would be divided by 36, right? 6 squared. Okay, number 11, kind of the same idea. The dimensions of of a rectangular prism, now we're talking about a prism, therefore they're asking us for the surface area and the volume. The dimensions of a rectangular prism are multiplied by a scale factor of 2. Now it doesn't say which dimensions, it just says the dimensions. That pretty much tells me that all of the dimensions of the prism were multiplied by 2. All right, so the length, the width, and the height all were multiplied by 2. So what happened to the surface area? The surface area changes, oops, I don't know how to spell area. The surface area is multiplied, since they changed the dimensions by 2, meaning they multiplied it by 2, the surface area is multiplied not by 2, but by 2 squared, which is 4. The surface area will be multiplied by 4. The volume, whatever that old volume used to be, it will be a new volume, which is basically the old volume multiplied by not 2 and not 2 squared, but 2 cubed, because we're talking about volume now, 3 dimensions, which will make the new volume, whatever the old volume was, times 8. It changes by a factor of 8. So if you change the dimensions by a factor of 2, then you change the surface area by a factor of 4, and you change the volume by a factor of 8, and so on. Okay, so for number 12, it says use the model shown to answer the questions. The first one is done for you. Tumbleweed County has a population of 256. The county's border can be modeled by a rectangle with these vertices. Okay, so you guys can see it right there in the picture, where each unit on the coordinate plane represents 1 mile. Okay, so each basic unit right here is 1 mile. This is 1 mile, another mile, another mile, another mile, and so on. What is the width of the rectangle in the model? They did that one for you. You can simply use counting here, 1, 2, 3, 4. Okay, or you could basically say the distance between A and D, and then use the distance formula, which you guys learned back in integrated 2, and you're going to come up with 4 units. Okay. What is the height of the rectangle in the model? The height, this height right here, you could count squares and say that's 1, 2, 3, 4, 5. That's going to be 5 units. What is the area of the rectangle in the model? Now, since it's a rectangle, it's a simple formula for the area, base times height, or length times width, which is 4 times 5. So it's going to be 20 units squared, or square units. What is the area of Tumbleweed County? Now, since each unit represents 1 mile, then that means that the area of Tumbleweed County is 20 square miles. And then finally, find the population density of Tumbleweed County. Okay, now I've talked about density in class, but if you don't recall, I said basically the basic idea of density is how much stuff, whatever that could be. It could be people for population density, or it could be the mass of a certain element for chemical density. How much stuff divided by how much space. Right, so in this case, the area of the Tumbleweed County. Right? Or in case of chemical density, how much stuff means mass. What's the mass of the element? And then how much space means what's the volume of where that element is. Okay, so in this case, how much stuff means how many people? 256. Let's scroll up to see it better. 256 people. And how much space is the square mileage or the area of Tumbleweed County, which is 20 square miles. So the population density, basically, just go ahead and divide that out, and I get 12.8 persons per square mile. That is the population density. In every square mile of Tumbleweed County, there is approximately 12.8 on average. Of course, you know, there's some people, more people in some areas, but on average, there's 12.8 persons for each square mile. All right, let's move on to number 13. It says the graph of a function in the form f of x equals a times the quantity x minus h squared plus k is shown. Use the graph to find an equation for f of x. Okay, so first of all, before I try to find my equation, I'm going to rewrite f of x as y equals a times the quantity x minus h squared plus k. I only do that because when I look into my graph, I'm going to look for an x and a y value. Therefore, I'm changing f of x to y to make it easier to substitute it in. Okay. Now let's go ahead and look at the graph. And what you want to look at the graph, the most important thing that you get to find is the vertex, which is basically the highest point here on the graph, and unless the graph happens to open up, in which case it will be the lowest point in the graph, right? So right here, that's the point that interests you the most. Go ahead and find the coordinates of that point. I can see that that point right there, this point right here, right, is 3, 4. And what you need to do is find another point on top of that, okay, that also this graph passes through, okay? And there might be many of them, but all you care about is just one more point that this graph passes through. So for example, I see one here, I see one here, I see this one right here, I see this one right here. You're looking for an exact point that passes through one of these lattice points of my graph, okay? I'm going to use this one right here because it seems to be one of the simplest one. Or although you could actually use the x-intercept right here, which is 1, 0. Actually, that might be better. Let's use that one, okay? So let's use this point here, which is 1, 0. You could also use this one, which is 5, 0. And like I said, there's this one right here, which is 2, 0. No, 2, 3. And then there's also this one right here, which is 4, 3. You have so many options in this case. Okay, all you want is to find one other point. You want for sure this one, right? You want the vertex for sure. It has to be that one right there. Okay, but you can use another one, and you have 4 options here to choose from. Any one of those 4 will do. Okay, I'm going to use that one because it seems to be the easiest one, okay, with the smallest numbers. So those are the 2 points you care about. You're going to go into the function right here and substitute in all of those values that I just gave you, okay? 3, 4 is the most important one. That's the vertex, and the vertex is represented by the letters H and K. The parameters H, K make your vertex. So right away you can see what H is 3, and K is 4. Okay, substitute those in. So it's going to look like this. Y equals A x minus 3 plus 4. Okay, and then the other point that we chose, 1, 0, that is basically xy. Okay, xy is at 1, 0. So you're going to substitute that one in for x and y. So y is 0 and x is 1. The only thing we don't have is a, and that's basically what we're going to figure out right now. Okay, do the calculations here. Simple. Inside the parentheses, first is 1 minus 3, which is negative 2. Negative 2 squared is 4, so what you have is 4a plus 4. Subtract 4 from both sides and solve. You're going to get negative 4 is equal to 4a. Divide by 4 and you're done. A is equal to negative 1. Take that a value, this h value, and this k value, and plug them all into this form, and you're done. Your function is, I'm going to go back to f of x, equals a, which is negative 1, times the quantity x minus h, x minus 3, squared, plus k, which is 4. That's your final equation of the graph. Of course, since it's negative 1, you could simply write it as negative, and then the quantity x minus 3 squared. You don't actually have to write the 1. Okay, but it makes it clear if I actually show it there. Okay, 14 is the same idea basically as 13. Okay, instead of a graph though, they're telling you that the vertex is 1, negative 3. So there, right there is already your h and your k. I'm going to go ahead and write that down. H is 1 and k is negative 3. And the only thing we don't know is a, right? But they gave us h and k. They also gave us a table from which to choose from. So they gave us a lot of different points. Just pick the one that you like the best to use as your x and the y. Okay, I am going to use 0, 2 because I always like to use 0. It makes everything easier when you plug in 0. Okay, so then write your function. You can take it from the last problem, or you should actually memorize it. A times the quantity x minus h squared plus k. Okay, they always look like that, right? Absolute value functions, cubic functions, quadratic functions, they always look the same way. Using the values that I just found, I am going to start substituting in. So for y, I plug in 2. A is the one I'm trying to find, so just leave it as a. For x, I plug in 0. For h, I plug in 1. And for k, negative 3. Okay, simplify, and I get 2 equals, now right here inside the parentheses is 0 minus 1, which is negative 1. Square it, and it's just 1. So 1 times a is just a. Plus negative 3 means minus 3. Add 3 to both sides, and you're done. A is equal to 5. You take that a value, 5. You take that a value and you take the h and the k values that we found earlier from the vertex, and you write your equation with f of x. So it'll be f of x is equal to a, which is 5, times the quantity x minus h, which is 1, squared, plus k, which means negative 3, minus 3. And that is vertex form. It's called vertex form because we can see the vertex right from it. The vertex is 1, negative 3. Now it says write it in standard form. So we're going to rewrite this in standard form. So what I'm going to do to write it in standard form is, first of all, I'm going to erase most of my work right here. And I am going to expand it so that I could write it in standard form. So like this. I have 5 times the quantity x minus 1 squared minus 3. So in standard form, it would look like this. 5, and then x minus 1 times x minus 1, because it's x minus 1 squared, minus 3. Use FOIL to multiply x minus 1 times x minus 1. Okay, so for that, you guys should be able to handle it, right? X times x times negative 1, and so on. it's going to be x squared minus x plus 1 minus 3. Combine the negative x and the negative x together to make negative 2x. So x squared minus 2x plus 1 minus 3. Distribute the 5 and you get 5x squared minus 10x plus 5 minus 3. And then the 5 and the 3 together make a 2. So it's 5x squared minus 10x plus 2. F of x equals that. This is vertex form. This is standard form. Alright, for 15, 16, 17, and 18, I'm going to skip the work right here because I feel like the majority of you guys are okay with factoring, so there's no point in me spending more time on this one. The only thing I will remind you of here is that on 17 and 18 as well, you need to take this 50x and move it over to the left side so that you can factor out, because they always have to be equal to 0. On this one too, subtract 6x and add 14 so that you could have a 0 on the right side, and that way you can factor. Okay, so I'm gonna let you guys work on these on your own. Why don't you go ahead and pause the video right here and then work on them, and then once you're done, unpause it and I'll show you the correct answers. Okay, so go ahead and pause the video right now. Okay, so here are the correct answers. For number 15, x equals negative 6 and x equals 2. Here's the factored form, 4 times x plus 6 times x minus 2. In number 16, you factor it by first dividing 2, and then you're going to get a difference of 2 perfect squares. So it's going to be x plus 4, x minus 4, and therefore your answers are x equals negative 4 and positive 4. Number 17, when you move the 50x over to this side, when you subtract it, you're going to get negative 100x plus 49. So factored out, you're going to get 2x minus 1 and 2x minus 49 equals 0. Solve them both and you get x equals 1/2 and x equals 49 over 2. And number 18, when you subtract 6x and add 14, you're going to get 4x squared plus 15x plus 14 equals 0. You factor that and you get x plus 2 times 4x plus 7. And then you solve and you get x equals negative 2 and x equals negative 7 over 4. Okay, those are your final answers for those. Okay, number 19 and 20, I'm going to do the same thing that I did in the last ones. I'm going to let you guys work through these. Okay, the only thing I'm going to help you out with is to write the quadratic formula. So let me write it down for you guys to use. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, there's the quadratic formula that you're going to use for these two problems. The only advice I will give you is on number 20. Make sure, once again, like I said in the last few ones, make sure you make it equal to 0. So you're going to subtract 2x. And then after you do that, put it in standard form, because otherwise you're going to think a is 14 and it's not, right? So first make it equal to 0 and also put it in standard form. And that way you can actually substitute in the correct values. Okay, so go ahead, pause the video right now. Work on the problems on your own. And then once you're done, come back and check your answers. Okay, so here are the correct solutions. For number 19, it's pretty straightforward. Plug in the correct a, b, and c values, and you will get negative 11 plus or minus radical 61 all over 6. 61 cannot be simplified any further, so you just leave it like that. Okay, just remember that there are two solutions here. Negative 11 plus radical 61 all over 6, and negative 11 minus radical 61 all over 6. Number 20 was a little bit, not more challenging, but a little bit more, it had a few more steps in it. Okay, once you subtract 2x, you get this. This is standard form. Negative 3x squared minus 2x plus 14 equals 0. Then you substitute in all your a, b, and c values, and you end up with x equals 2 plus or minus radical 172 all over negative 6. And this is where most of the common mistakes happen. People will not get 172 here because they mess up on the signs right here. Okay, so you should have 172. Simplify that 172 down to 2 radical 43, which is the same thing. Great, use a factor tree for that, but you get 2 radical 43. Also, at the same time, I took this negative sign that was with the 6, and I moved it up here with the 2. You can do that, okay, if you want to make your problem easier. You're basically saying, I'm going to multiply the top and the bottom by negative 1, which you can do on any time. So I wrote it as negative 2 and positive 6 in the denominator. Okay, how come I didn't do it here? You did, it's just that it's plus or minus, but the plus became minus and the minus became plus, which is the same thing. And then at the end, I had the 2, and the 6, and they actually simplified down to 1, 1, and 3. So it's negative 1 plus or minus radical 43 all over 3, and that is your final solution. If you left the negative in the denominator instead of up here, that's also fine. It's still the same solution. Just make sure that if it's a multiple choice problem, you know that you can always take that negative and bring it up. All right, 21 and 22 are the same thing. It says solve each quadratic equation by any means. Identify the method and explain why you chose it. Express irrational answers in radical form, and also use a calculator to approximate your answer rounded to 2 decimal places. So they want the answers both in radical form and also as an approximation rounded to 2 decimal places. Okay. Number 21, do not let it confuse you. It should be pretty straightforward, okay? Now it says use by any means you want. So you could always go to the quadratic formula. You can go to factoring. If you're going to use either one of those two, you need to move the 64 over and write it as 4x squared minus 64 equals 0, right? If you're going to use factoring or the quadratic formula. In which case it could work, right? This is a perfect square minus a perfect square, and therefore you can factor it out. Or you plug in a equals 4 and c equals negative 64 into the quadratic formula. Since b is missing, you would plug in b equals 0, and you would also get the solution. Okay, I'm not going to go that route though. You can do that, but I'm not going to go that way. I'm going to go, I think, an easier way where it's already basically set up for me. Since there's only one x value here, only one variable, I can isolate that x by simply taking the square root of both sides. And when I take the square root of both sides, I am going to get 2x is equal to plus or minus the square root of 64 is 8. And then all I got to do is divide by 2. And that gives me that x is equal to plus or minus 8 divided by 2 is 4. So my solutions are 2, positive 4 and negative 4. And I'm done. You could have also divided by 4 first and then taken the square root, okay? But I noticed that 4 was already a perfect square, so I went ahead and took the square root as it was, okay? But sometimes you're going to have to divide by that coefficient first before you can actually take the square root of both sides. All right, number 22, we examine it and we try to find the perfect method. Our go-to choice is probably always factoring. So you can try to go with factoring. Let's see, a is 2, b is negative 4, and c is negative 3. So a times c is negative 6, right? 2 times negative 3. I'm seeing if I could factor. Two numbers that I can multiply to make negative 6, but when I combine them together, they make negative 4. 1 and negative 6, no. 2 and negative 3, no. It doesn't seem to work. Nope, doesn't seem that's going to work. Okay, so if that doesn't work, let's go quadratic formula. Your other option is always completing the square, but in this case it's not a good option because the coefficient of x squared is 2. If it was 1, it would be perfect and I could actually complete the square, okay? But it's not, so I'm going to go with the quadratic formula. So we're going to use x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Plug in those values. Let's see what we get. We're going to get negative b, which is negative 4, so positive 4, plus or minus the square root of b squared. B is negative 4, square root is 16, minus 4 times a, which is 2, times c, which is negative 3, all over 2a, which is 4. 2 times 2 is 4. Right, simplify the inside of this radical, so it's going to be, continue here, 4 plus or minus, it's an equal sign, radical 16, and then 4 times 2 times 3, that's 8 times 3, 24, 16 plus 24, which is 40. So it's radical 40 all over 4. 4 plus or minus radical 40 all over 4. And now I'm going to simplify that radical 40. Now if you have forgotten how to simplify radicals, usually we go with the factor tree. Break that 40 down into 4 and 10. 4 is 2 times 2, so break it down into 2 times 2. 10 is 2 times 5. And there you go, those are all the prime factors of 40. I see a pair of 2's and then a 2 and a 5 that have no pairs. Okay, so that 2 and that 5, since they don't have a pair, they're both going to stay inside of the radical, which makes 10. And these 2's will go outside, but only one will make it out. So it's going to be 2 radical 10. Okay, so radical 40 is 2 radical 10. So this gives me 4 plus or minus 2 radical 10 all over 4. And now I can simplify this 4, this 2, and this 4, okay, by dividing them all by the same number. So my final answer, and I'm trying to make it fit somewhere in this space. Let's move it over here. My final answer is going to be 2 plus or minus radical 10 all over 2. And that is your final solution for number 22.